Hi everyone, welcome to NX70X videos. What we're looking right now is variable capacitors matching system for 75 meters, and right here we got the one for 160. Okay, these ones, they are integrated into a tower. It's a 25 feet tower, just going up and up, and as you can see right there goes the mast, which is 64 feet altogether. 44 feet, 64 feet altogether. Okay, and at the top, let me zoom into. Okay, at the top of the vertical, we got guide wires over there. At the top, we do have some wire, capacity hat wires up there for 3 40-foot long capacity wires, capacity hat wire up on the top. That's what we got there, and they basically roll. Let me point it out. There we go. Oh, we got three 40-foot wires up on the top to make it more simple, and they comes down the vertical. There's the tower, and what you see over there, what we're using to do the matching system is the gamma match. Basically, that's the gamma match tubing. This comes down all the way to the bottom of the, close to the tower. Comes down about 3 inches from the ground. Over there, that's the way we got it set up at the moment. And we got a PVC pipe, which we're gonna change that to make it look better, making the separating the gamma match from the tower. The farther it goes, the more different adjustments you, the closer to the tower or the farther from the tower, does how the adjustments is gonna be also. If you put it too close, it's gonna give you a different readout. If you put it a little bit far away from the tower, it will give you a different readout. And that tubing, aluminum tubing, it goes way up on the top. It's a 14. Oh, this is I think it's a 25 feet, 24 feet. Yeah, 24 feet tubing out of it, and basically it almost goes all the way for 160. It goes pretty much all the way to the top. Put some brackets up there to tie it, put it together with the tower, one leg on the tower, and comes back and get tied over there with some brackets, U-ball brackets, to the mast. I mean to the gamma match. That's for 160. We got it set up on 1870 frequency. Basically, that's where we operate. It's very narrow, and but very efficient, low angle takeoff on 160. And now we're coming down. There's the that's for 160, and this is the matching system for 160 also. Got a variable capacitors over there, and door net, what is it, 200 picofarad, 10 kW matching system on it. wheels, you can see it right there. Let's give you a much better view. Let's focus. 10 kilovolts, 200 picofarad, and got the variable capacitors. They're good for 500 watts, basically, no more than that. We're gonna switch all this later on to buy capacitors good for 1.5K legal limit. Same thing with this ones. They're for kind of little low power, 500 watts also, but we're gonna get a bigger ones for the legal limit. Okay, and on one side of the tower, okay, this is the 75 meters here. Let me show you the 75 meters matching system on it. It's aluminum wire. This time it's not a tubing. We got a aluminum, very 1/4 inch aluminum wire. Goes to the bottom, and here's the attachment. We got a 12 gauge wire. Oops, sorry, where are we? Right there. Got 12 gauge wires going inside. There's the variable capacitors, which is they parallel with the two capacitors over there. And then there it goes, the coax connection. Very simple thing to do on it. It's not very difficult. This design is being made by the November 8 Mike Sierra Mike Luis Carlos. He's the one who designed make all this matching system on it. And this other one, same thing. We do have the feeding point of the variable capacitor here up on the top. We got ground going that way. That's the ground connections. And we got the feeding point here. Connectors right over there. That's the connector side here, which comes up into the positive side at the bottom of the variable capacitors. It comes in, it comes up from this side here, comes up, goes in at the bottom, comes out from here, and it goes into the gamma, the gamma match here. Alright, and something this one here. Anyway, that's what we got, and we got the ground from the connector over there. Just pointing out the ground from the connector, it goes down to the base of the tower on the other side, to the other leg on the tower, and then we got some ground wires right here. All these are ground wires. Some of them there in the future. We're just gonna put a whole bunch of ground wire radials at the base of the tower, at least some 120 foot long, make it more efficient that way on the two bands. So we got the ground base. The ground is attached towards my link fence, using as a ground. It goes all the way around the property. As you can see, it goes all the way. It's a metal link fence. It goes all the way around the property over there. That's what we're using. So we'll come back down here towards the 75 meters matching aluminum wire. Yeah, I would think it's about 10-20 feet long. It's about 10-15 feet long, and then we're using the other leg at the top to do the matching for 75 meters over there. Right over there. Sorry about that. Right there, that's the matching aluminum tubing, which goes, there's the leg of the tower. It comes down to matching box, which is right over there. That one for 75 meters. That's 160. The 160 goes with this gamma match also. The two are two gamma matches. So that's the way we basically figure out how to work a 64-foot vertical tower with the mast with the vertical tubing on top of the tower. Make it work on 75 and 160. And that, and then the coax goes inside the station over there into the station from the back side. And we got some more wires up there, so we'll coming back here. Another thing I was gonna explain, explain real quick. It's the this gamma with this gamma match wire also. You see this tubing. This is a tubing which stabilize the gamma match here. Make sure it doesn't flip back and forth with the wind, because if it's windy, you start moving the SWR, it's not gonna go up back and forth. It's gonna go up and down that way. So if you put it as on 75 meters on this setup, if you put the gamma match closer, the frequency is gonna go up. The tuning is gonna go up low SWR. If you opening towards the outside, the tuning is gonna go down on 75 meters. It's kind of about every inch. It goes from 83 to 38 to 79, 380 to 79 to 3770. We basically got it set up for the window, for the DX window on this 75 meters spatial. Alright, that's pretty much, and hopefully that helps a little bit. We're planning to change all this setup, all this two matching system. We're gonna put it on just one box. Make sure everything is isolated and not too many boxes, and we're gonna lift it up from the ground. Make sure if it's snow, it's gonna be well protected. So there are a few changes we still gotta do, but that'll give you an idea basically what has been done in order to tune a tower with the tubing up on the top with the guy wires, with the guy ropes, basically not wires, guy ropes, and 40 foot capacity hat up on the top. Alright, hopefully you enjoy. Any questions, please leave a comment, and I'll say 73. Thanks for watching, and see you on the air. Hi everyone, welcome to NX7DX videos. We got here a new video related with a relay box for a receiving antenna, triangle basically receiving antenna down here. It goes right over there, and it goes right at the bottom side. It holds right there in that corner. It goes up, so it comes down one direction. Let me back fix zooming. Okay, and so this is the positive and negative. This positive is pointing towards the north, and this is pointing towards the negative point, pointing towards the south. It's basically left and right in order to change directions with this little relay box here, which is being made by November 8 Mike Sierra Mike. And to give you an idea, very simple, just a little relay switch over there, which comes up. One for one side, the green goes to one side, the red goes to the other side. That's where this little blue box over there, the relay, make the switches left and right to eliminate noise. To get rid of the noise and bring it up just the signal, just the voice from the other station. It works very good, works very efficient. Tested out on 75, 160 and 40 meters. On 10 meters, things like 18 meters, 15 meters, things like resonate as an antenna, very noisy. But on the lower bands, it's phenomenal. Okay, so that's the relay. And we got right below that here, those little wires over there, right there when I'm pointing. Those ones, we got one that to activate, to send power to the relay. One positive, the red is positive, the black is negative. So this one uses the speaker wire. It goes inside the station, all the way inside to the shack over there, in order to bring it up, in order to give it power. This speaker wire from the house is connected to the switch to turn on and off the switch. When the switch is on, switch it to from one side. When the switch is off, is on the other side of the leg. Alright, switch on. So get the signal from the north side. Switch off, get the signals from the south part, from the south side. So that little wire, these two little wires at the bottom of the relay, that's to send power from the station, activate the relay to the north or to the south, basically. And right here at the bottom, we got the connections. Connection from a regular satellite dish, coax connections, which goes into a RG6 connection here. RG6 connection, and this is we had a we got a friend over there. Got a little friend coming down. Okay, we got a ferrite in order to eliminate the noise, also make the signals a little more quiet that way. All right, so that's very simple. We got the connections right over there coming from the relay. Orange wire goes on the other side of the leg for the north side of the antenna, and we got the ground. Got a ground connection here. We do have this ground connection, comes up to the metal rod here, and on the other side, that's pretty much it. Very simple. Center. From the coax, it goes to the center, and the ground, it goes to the ground, and that's pretty much it. Thanks for watching. This is NX70X. This is the work from November 8, Mike Sierra Mike, and this is a station from NX70X. There we go, quad, and we got the vetical up there. Got the vetical climbing way up. So 64 feet vetical. Just up there. That's what for 75 and 160. And we got the quad in there on the crank up tower. And we do have a log periodic multi-band up there, very efficient, it work on 160, believe it or not, 40 and 160. So that's pretty much what we got from our stations, and we got some loops with the connections over there up on the tree from my 160 loop and 75 meters delta loop. Basically they come all the way around the property up on that tree over there, right there. There's the feeding point for the two antennas, and they go way long all the way across the property, and it goes up. It goes up, up, and up on the tree. Goes up on the tree. It comes back around, and it goes up into that tree also. It's up into that tree and comes back all the way around here. You can see the wire going in there. Anyway, 73s from the log periodic NX70X. Oh, by the way, with this log periodic, if you look at got two boom elements. The way the log periodic is set up, one boom on the one element on the top and one element on the bottom. That's the way they scattered the elements. Let me give you a better view on that one. See, one on the top and one on the bottom. One element at the top. Let me get a closer look. There. Oops. There. That's the way the Tenediene log periodic worked. Remember, Tenediene got a T10, 10 elements, 24-foot boom log periodic. 73s from NX7 or NX70X.